Hello, testing, testing. I think my mic is working. Hello, hello. Should I press it closer to my face? Bam. Hello. Yash Esports. Do you actually play esports? Are you a gaming channel? I'm trying to widen my chroma. Oh, there it is. No, not gaming channel. Do you do esports? Oh, you do esports. Cool. Bruzilla says I switched to Linux. Alright. Hello, by the way. These are my hands. What's up? Okay. So we have been reading this book, this system design book called System Design Interview, An Insider's Guide by Alex Shu. Big hands? No, it's probably the camera angle. I'm actually a pretty not muscular person. Yeah, we've been reading this book called System Design Interview by Alex Shu because I have system design interviews coming up. So if you were here last stream, you might have recalled we did chapter 1, 2, 3, and then 4. Why the heck are we skipping to chapter 8? Because I have a feeling that in my coming interview, they're not going to ask me such low-level stuff like consistent hashing key value store or unique ID generator. From past interviews, at this current level, they usually ask you to design some big application or like an actual app. So that's why I decided to skip ahead to URL shortener because that seems more applicable to upcoming interviews by intuition. Yeah. Okay, here we go. Okay, chapter 8, design a URL shortener. Maybe I'll make this bigger. Now close this down. Okay, do you guys want to take a guess at how this is done? Should I take a guess at how this is done? We probably need a way to do I have scratch paper here? I don't. Oh no. Okay, I have scratch paper. Can you use ChatGPT in an interview? Oh, that's a good question. They specifically told me in one of the rounds I will be evaluated on how well I can vibe code using Cursor. So there's probably going to be one day over the weekend where I will practice that too. Whether or not I will stream that is up to me. But yeah, how do we design a URL shortener? I'm gonna try taking a guess first at how this is done, and then when I read it, I'll see how wrong I am. How do you guys think this is done? I think so. We definitely need a way to submit our long URL, right? And then store the short form of it. We also need a way to like generate, somehow map the long URL form to the short URL form. So we probably need some sort of data store for that. We probably need some sort of API to ingest the long URL and then somehow generate a shorter version of that and then store it into our database. Okay, the question is, how the heck do we get a browser to recognize the short URL? Like, we have no control over that, right? How do we do that? That's my question. Maybe that's something I'll just have to read. But let's say you have some sort of API to convert the short URL back to the long URL. That's probably something we need, right? Maybe the browser can call that API or whatever. You can't API everything out, do it manually. Really? If not API, then what else do you do? So what I'm thinking is, I don't know if y'all can see this, but let's say we have, I don't know, just a freaking backend API over here, right? And then this thing has an API that takes in the long URL, and then we probably need some sort of data store, like here's a data store. Is it possible for me to zoom in my camera? Is that possible? Oh my goodness, this is such a terrible angle. It's not even auto-focusing, right? Great. Fine, this is fine. We probably need some sort of data store to store, like maybe literally all the columns are just like the long URL as the primary key mapped to the short URL. So we need that, you know? Okay, let's just write out the names of the APIs. We probably need a way to just store convert the long URL to short URL, right? So we need a shorten URL API, and then we also need a short URL to long URL API to long API, where you plug in the shorter API and it returns the long API. What else do we need? Yeah, I really don't know how we can possibly control a browser to like automatically call us when a short API is entered into it. I really don't know how that works. But yeah, this is my, is it bad that I think that's this simple? I mean, if we were to ask, yeah, this is probably not the answer, right? This is probably not the answer. It can't just be this simple. I mean, if we were to make it more complicated, if we were asked how to scale this out in a real interview, maybe we can be like, oh, we have a cluster of backend servers, and then this cluster of backend servers is fronted by a load balancer. So we can support many calls at the same time to the API. And then our data store over here, we can probably scale that out by, we can do database replicas, right? Where this is like the freaking master database that we write to, and then to ease up the load to the master database, we can have a bunch of like slave databases which keep copying from the master database, but we send all the writes to the slave databases, so the master database doesn't have so much like load on it in terms of like reads. Okay, so these are my slave DBs. We can also probably do a thing where we shard the databases. Ooh, I never thought about sharding and replicating at the same time. Sharding is when you kind of split up all the primary keys into different sections. Maybe like primary keys A through M are in one cluster or instance, and then M through Z are in another server. Yeah, alright. Alright, this is my very naive noob solution on how this is probably done. This is probably wrong though. Okay, let's actually read the article and figure out how to do it properly and see how wrong I was. Okay, we're back here now. Design a URL shortener. Okay, this is probably the part where I will be a little bit more quiet since there's a bunch of reading. Given a long URL, return a much shorter URL. Given a shorter URL, redirect to the original URL. Okay, so we aren't in control of a browser then. We're literally like, we just need an API that, given the shorter URL, redirects to the original URL. Okay. High availability, scalability, and fault tolerance considerations, okay? They're doing some back of the envelope estimations. So they're like, what is the traffic volume? 100 million URLs are generated per day. So the back of the envelope estimation is 100 million URLs generated per day, write operations per second, 100 million divided by 24 hours divided by 3600 seconds is equal to this. So you'll have 1160 writes per second. Read operations. So we're assuming of read operations to write operation ratio 10 to 1, meaning we have a lot more reads than writes. Read operation per second is the write operations per second times 10 is equal to this. That's a lot per second, okay? Assuming the URL shortener service will run for 10 years, this means we must support 100 million. Oh, because 100 million URLs are generated per day times 365 days times 10 years equals this many records. Assume the average URL length is 100 characters. And 1 character is a byte. So this many records lifespan times 100 characters times 10 years. Wait, don't they already take into account the 10 years over here? So lifetime we need 365 billion records. .365 times 100 bytes times 10 years. Yeah, don't they already take into account the 10 years over here? Oh wait. So you would just multiply 365 billion records lifetime times 100 bytes per record. Okay, I don't really get it actually, but I think it's fine, we can skim over this. Step 2, propose the high-level solution and get buy-in. So the API endpoints. Oh, what's that? You can't API everything out, do it manually? We're designing APIs, Bruzilla. So the first API is URL shortening, create a new short URL. Client sends a post request, which contains the original URL. So like this one. the request parameter long URL string, return the short URL. Number 2 is we get a short URL and then we return the long URL. Oh, wait, that was basically my plan. I was pretty spot on actually, at least for the API stuff. So we do just need 2 APIs. One with the short URL, one with the long URL. Okay, I wasn't too far off with the assumptions, but I guess in a regular interview I could just ask them what I should actually design. URL redirecting. Visit the short URL. Oh wait, is this how you... I think they're explaining how to actually handle the redirect now. Once the server receives a tiny URL request, it changes the short URL to the long URL with 301 redirect. So the client visits the short URL. And we do a 301 redirect somehow with location long URL, and then we visit the long URL. Okay, so we still have to return the long URL regardless. That's the most important part. 301 redirect versus 302 redirect. 301 shows that the requested URL is permanently moved to the long URL. Browser caches the response, and subsequent requests for the same URL will not be sent to the URL shortening service. Instead, requests are redirected to the long URL server directly. It's Raj says, I heard that system design is difficult to learn. I think it's difficult to learn. Yeah, so you just gotta study a lot, hope for the best. 302 redirect means that the URL is temporarily moved to the long URL. So I guess it's not cached unlike the 301. Subsequent requests for the same URL will be sent to the URL shortening service first, then they are redirected to a long URL server. I have a question. So when we return a HTTP status of 301, does the browser automatically redirect? Is that a thing? Hold on, let me ask my best friend ChatGPT. Does browser redirect automatically when we get 301 or 302 status message? Oh yes. Oh, that's how you do it. Is it worth learning system design nowadays? I think so, yes. For entry-level positions, they will mostly ask leak coding questions. So if you're entry-level, I guess focus on leak coding. For more mid-level positions, they will ask system design, unfortunately, so gotta study that. For senior positions, they will definitely ask system design, so you have to study that, unfortunately. At least that's how it works in USA. I see. That's so cool. So you just, when our API returns when our server returns a 301 or 302 status message, it will automatically trigger a redirect in the browser. That was something that I did not know. Okay. The most intuitive way to implement URL redirecting is to use hash tables. Okay. Assuming the hash table stores short URL, long URL pairs, URL redirecting can be implemented by the following: hash table.get short URL. What do they mean by hash table? Aren't most, if you use a relational database with the primary key of the long URL, that does the trick, right? I think it does. Wait, best friend ChatGPT. What is a hash table? Is a data structure. Don't we want to use some sort of data storage here? Is a database with primary key same as key of hash table the same? Primary keys are typically indexed automatically to speed up queries, B trees. Interesting. So database primary keys are like log n time, I guess, and then keys of an actual data structure are O1 time. Okay, so they're saying naively we can store everything into a hash map or hash table. I wonder how that works when you try to scale it up though. Let's keep reading. We must find a hash function f of x that maps a long URL to the hash value. Okay, so the data model. In the high-level design, everything is stored in a hash table. This is a good starting point. However, this approach is not feasible for real-world systems as memory resources are limited and expensive. Yeah, that was what I was thinking. So we gotta store it in some sort of data storage, right? Maybe a database. And then to make it faster, we confront it with some sort of cache. Oh, I think that was what was missing from my design here. I gotta front end with a cache so it can actually be fast. And then that cache can use key value mapping to make it O1 time if it's actually in the cache. Yeah, that's probably the way to go. The simplified version of the table contains 3 columns: the ID, short URL, long URL. Okay, what's the ID? Maybe the hash value? Hash function is used to hash a long URL to short URL, also known as a hash value. Okay, they're talking about how to compute the hash value. I mean, in practice, we'll probably have some sort of given library or API that generates the hash for us, right? Surely something like this is already out in public. Okay, so they're just talking about how to generate a unique hash URL redirecting deep dive. Cool, so they're starting to scale it up. 8-8 shows the detailed design of the URL redirecting. As there are more reads than writes, mapping is stored in a cache to improve performance. Yeah, that's probably what was wrong with my initial design. We got a fronted with the cache. Alright. Fortuner says, yo ho. Hello. Hey Fortuner, how you doing? The flow of URL redirecting is summarized as follows. User clicks the short URL link. The load balancer forwards the request to web servers. If a short URL is already in the cache, return the long URL directly. You're doing good. Good to hear. If a short URL is not in the cache, fetch the long URL from the database. If it is not in the database, it is likely a user entered an invalid short URL. The long URL is returned to the user. I see. Yeah, we didn't take care of this in our naive plan, huh? If they enter an invalid short URL. Wow, okay. This is actually really simple. If we ignore the how we generate the hash part, which I don't think I'm too concerned about, I have a feeling they are not going to ask me how this is going to be done. I think. If they ask me, I'll just say find some sort of library online to generate a hash. Huh. Okay, so all in all, the design of the URL shortener is basically just two APIs, right? One to convert the long API, not long API, the long URL to a short URL, and then store it in your database, and then return to the user the short URL. And then API number 2 is given a short URL, convert it to a long URL, and give it back to the user. That's literally it, right? So we just have a database fronted with a cache that our web servers can interact with. And then we have a load balancer. That's literally it, right? Okay, so the wrap up. Rate limiter. A potential security problem we could face is that malicious users send an overwhelmingly large number of URL shortening requests. Rate limiter helps to filter out requests based on an IP address, okay? Hey, we read this chapter, how to design a rate limiter. Leaky bucket algorithm. Token bucket algorithm. I think I still remember that. Web server scaling. Since the web tier is stateless, it is easy to scale the web tier by adding or removing web servers. Database scaling, database replication, and sharding are common techniques. I have a question on that. How does sharding and replication work at the same time? Do you just have multiple copies of each shard? Do you shard it first, so divide all the primary keys into their own server and then replicate those servers so they each have their own master? Each shard has one master and several slaves. Is that how it works? How does database sharding and replication work at the same time? Is it a good idea to use both at the same time, or just stick to one? They're often used together. So replication is just literally duplicating your database for the leader and follower. and then read from the replicas. Sharding is data is partitioned across nodes. Each node stores only a subset of data. Common shard keys are user ID, geolocation, how they work together. Shard 1, I see. So shard 1 has their own primary database and its own slave replicas. I see, makes sense. So you basically shard first and then replicate. Yeah, how would replicating work and then sharding work? Okay, analytics. Integrating an analytics solution to the URL shortener could help to answer important questions like how many people click on a link, when do they click on a link. We discussed them in detail in Chapter 1. Please refresh your memory on these topics. Okay. Apparently there's a better tutorial here. Okay. So overall, the design of this is pretty simple, huh? Though they kind of skimmed over, they did go into detail of how to write the two APIs. This was just kind of a random thing that they talked about, like, if you visit the tinyURL server, then it returns a 301, but it's like, okay, how does this work? Do I have to buy? How do I somehow obtain this tinyURL URL, you know, and get it under control of me? Okay, let's say I just have access to any URL I want, right? Maybe I can have any tinyURL URL. Sure, I can front it with a server and then code it to return. Yeah, code it to call the long URL to short URL API, right? And then in its return the status 301 with the long URL. Wait, how does that even work? How do I literally get... How do I get my hands on literally any URL? For the URL shortener system design question, how do I get my hands on the tinyURL link in my control? And then return the 301 status from there. Do I have to buy the URL? You own or assume ownership of a domain. You assume that you own a domain. So assume we own a short domain like show.rt. User creates a short link. Okay. Oh, I see. So we just need to buy one domain, and then those are just sublinks in our domain. Got it. Okay. When the user clicks the short URL, oh, it goes to our backend. And then we return the HTTP status with the redirect. Oh, I see. I think I get it now, okay. Okay, I'm gonna start writing down my notes. PU says, yo, what's up? I'm doing good. How are you? I'm learning how to make a URL shortener. Apparently it's not as bad as I thought. I was actually kind of half right in my before reading implementation. Yeah. Okay, time to start writing. Wait, hold on. Actually, I'm still confused. For this second API, how exactly does our service interact with this? I guess the general behavior is whenever they visit our domain / this specific hash that they have, we need to design this path, this URL path, to call the second API and then redirect using that. That's kind of the idea, I guess. I guess there should be frameworks that can handle that, right? Using routes. Okay, sure. Okay, so URL shorteners, there's 2 APIs. Still on the same topic, chat, how many hours you study daily? Actually, I'm not on the same topic. Well, I'm still on the same book. I'm learning we're on chapter 8 right now. We're learning how to do URL shorteners, system design. As for how many hours do I study daily? 1 to 2 hours. Literally however long I stream. I have no motivation to study outside of streaming. I need someone to watch me, or else I have no idea. Or no motivation. Okay, so the shorten URL, you take in the long URL as a string maybe, and then you would generate the short URL, store the mapping, and then return the long URL. Yeah, and then the second API is converting the short URL to long URL. Maybe let's call this API like redirect or something. And then out would be this short URL. Okay, so if we were to just implement these 2 algorithms or 2 APIs purely, we would so there's a client and then there's our API servers. You know, I'm probably not going to write down or draw out the optimizations like load balancer. Should I? I think I'm just going to draw out the main idea. The API servers, and there's a database. This is the DB that stores ID, short URL, long URL. I'm not sure why we need the ID. Why do we need an ID? Why do we need an ID here? What use of it do we get? Wait, this flowchart is confusing me. Input is long URL. Is the long URL in the database? Yes, then return the short URL. If no, then generate a new ID. Convert ID to short URL. I guess they're making the hash here. Say the ID is short URL, long URL in DB. That's kind of confusing. Why are they combining the shortening and the redirecting API on one flowchart? We want the URL shortening flow to be logically simple and functional. That doesn't seem simple to me. Why are you combining two APIs into one? User clicks a short URL. Load balancer forwards the request to web servers. If a short URL is not in the cache, fetch the long URL from the database. Long URL is returned to the user. Right, I mean, I still don't know why we need the ID in here. Oh wait, the distributed unique ID generated is worth mentioning. Its primary function is to generate globally unique IDs, which are used for creating short URLs in a highly distributed environment. Implementing a unique ID generator is challenging. Luckily we have... Okay. I don't think this is useful. Can we ask ChatGPT? Best friend ChatGPT. Is storing a unique ID outside of the short URL and long URL in the database useful? Harder to evolve encoding schemes. Numeric ID plus derived shortcode. ID guarantees uniqueness. Shortcode becomes a representation, not the source of truth. Support custom aliases later. Rebuild shortcodes if needed. Uniqueness without collisions. Random short strings require collision checks. Numeric IDs don't. Numeric IDs are faster to index, better for joins. The ID is the primary key and source of truth. Avoids collisions. But you're supposed to avoid collisions with your short URL, right? Okay, why do we need to guarantee uniqueness? Doesn't the short code already needs to be unique? Shortcode must be unique externally, but we still want a separate internal mechanism that guarantees uniqueness easily and safely. Guarantee uniqueness first, then derive the shortcode. I guess it's guaranteed to be unique. If you're inserting it into the table, okay, I guess it just, in the off chance that your short URLs are not unique, like God forbid that happens, but if it does, it ensures that you don't have some sort of error when trying to insert it into the database, I guess. Yeah, database constraint rejects duplicates. Okay, sure. I still think that you should have some sort of function that can dependably generate unique short URLs, no? That should be ideal. So it's not required though, the ID, but I guess it's a nice to have if you want to avoid, like absolutely avoid collisions in database insertions. Okay. Should we have some sort of... Should we have some sort of UI so that people can actually, have a nice, UI to insert their URLs into when they're making short URLs? I guess that's not super required, right? You can make do minimally with just a backend, and people can call the API directly. So, yeah. Sure. And then the redirecting part. I guess you would need some sort of framework that can support routing, like maybe Remix. I think Remix does something like this where you can define routes and the behavior of those routes. Yeah, and then you have your tiny URL server. Yeah, that's a good name for it. Tiny URL server route. And then I guess you can define the behavior of this to look at the DB and then redirect. Yeah, okay. So for scaling of the API servers, we can put multiple servers plus a load balancer. And then the database too, we can scale with, well, caching isn't really scaling, right? Well, it kind of is, just for speed thing. Scaling, front end with the cache. Multiple caches even. Yeah. Have we learned how to scale up caches in chapter 1? Oh, here, chapter 1. Caching. Not really, actually. I imagine we can put a load balancer in front of a cache. Maybe even shard it. Load balancer can be used for any type of server, right? Or is sharding just for databases? That's a good question, actually. Surely you can put a load balancer in front of a cluster of caches, right? And then replicate, no, not replicate, shard them. How to scale caches. Can you put a load balancer in front of a cluster of them or shard them? Do not put a load balancer in front of caches. Shard caches using consistent hashing. Some key may go to different cache nodes. Same key may go to different cache nodes. Wait, that's what I'm saying though. Maybe you can distribute the primary keys in a smart way. Like if you have two servers, A through M go in server 1, M through Z go in server 2, you know? The correct approach, sharding, partitioning. Oh, wait. Oh, so they're saying load balancing. I see. So load balancing is a bad idea because you don't want to store this you don't want to try storing multiple copies of the same information in different servers, because if you update one, it's hard to keep all of them consistent, with each other. So sharding, decide which cache node owns a key. Okay. So you can shard and replicate. The replicas? So do the replicas need a sharding replication? Do replicas not use load balancer? Okay. In a real interview, I'll just say replicas, not load balancing. Can be used for caches too. Can shard and replicate at the same time. Cool, okay. I mean, yeah, this is pretty simple, right? It feels pretty simple. You just have a client, API servers that oh wait, hold on. This tiny URL server probably needs to call the backend API, huh? And then you have a database that stores your short URLs to long URLs. And then your tiny URL server, maybe you can code it in like Remix, a framework that supports routing. So you have your domain slash something, and then you can take that slash something, look it up in your API that converts the long URL to, the short URL to the long URL, and then return it as a 301, 302 status. Yeah. Let me just confirm my understanding with ChatGPT. Hold on. Is this understanding of URL shortener correct? I have API server that supports two APIs. Shorten, convert long URL to short URL, store and return the short URL, and then redirect, convert long URL to short URL, Mythic Wavy says, hello, I have a question. Do you like math to some degree? The easy maths, yes. I wouldn't say I like all math. Maybe because I don't have a good experience in math in school. But yeah, or at least decent at it. I wouldn't say I'm decent at it either. I'm good enough to pass tests at schools, I guess. I wouldn't say I'm super good at it though. Yeah. Do you like maths? Yeah, I don't think I'm the type of person who really likes maths. I think if it helps me make the apps that I want to make, then maybe I like it. But usually I'm not like hopping to do math. No, because I just spent 10 minutes on one question. Which question for a stupid answer? Dang. What are you working on? Calculus? Geometry? We'll have one that supports routing, maybe with Remix. So we can do our main URL slash some route. Calculus? Oh, calculus. My answer wasn't even wrong, it was just terrible wording. No. Wait, what do you mean terrible wording? How do you get a calculus problem wrong with terrible wording? Did you forget your units or something? Then we can take the sum route, plug into the short to long, the redirect URL, and our front end server can return HTTP status 301 or 302 with the long URL to redirect. Okay, ChatGPT, please tell me if my understanding is right. You're very close and your core understanding is correct. No, so I'm slightly off. You have two core operations, short and long, redirect, short URL path slash some route is extracted. The redirect should not be handled by a front-end server in the usual sense. The redirect endpoint is a back-end responsibility. Should be extremely fast. Interesting. An API slash redirect service. So the redirect endpoint should be a back-end responsibility. Handled by API server. It will work? Okay. Not really. We expose a lightweight HTTP endpoint at slash shortcode. This service looks up the shortcode in CacheDB. How exactly do we do that though? How do we make a backend service that responds to a, what do you call it, sub URL? Most backend frameworks allow you to define routes with parameters. Okay. So backend frameworks allow you to respond to sub URLs too, okay. Just like front-end frameworks. Okay, sure. Mythic says if you get asked to round to the nearest integer and your answer was 1754.75, what would you do? Round to the nearest integer, I would probably do 1755, right? Is that what you did? That would be my intuition. What would the correct answer be? That's what I did for 10 minutes. Wait, then what is that? What is round to the nearest integers? 2000? What? Why? I don't understand. Why? Did they say round to the first significant digit or something? Like only one significant digit? Why is it 2000? Did they specify significant digits in the problem? No, they didn't? Well, that's pretty bullshit. Round to the nearest integer. Yeah, makes no sense to me. I see, you can define behavior for sub URLs. So can be backend framework. Support sub URL. Okay. Well, Mythic, I'm sorry you had trouble on your homework. That sounds very annoying. I would have done 1755 too. Can be part. Can be same servers as API servers actually. Wait, so how do we distinguish between the calls to the calls to make a new tiny URL or a call to actually redirect to a tiny URL or redirect a tiny URL? Do they talk about this? How do we distinguish between a call to redirect from a tiny URL and a call to make a new tiny URL? Oh, we can distinguish between a post and get method. Create will be a post, redirect will be a get. Oh, okay. Post versus get. I see. Okay. Actually, you probably don't need to do that, right? You can just define different APIs for them. Yeah, using different APIs, okay. or just different APIs? Got it, okay. Okay, I'm pretty sure we're done. So, URL shortener, two APIs, one to shorten the URL and one to lengthen the URL. So the client can make different API calls for API servers. One API call can just be to make the tiny URL. In this case, we would make some sort of hash function to make the short URL and then store in the DB where we store the short URL versus long URL. Yeah. And then we can have we can define sub-URL behavior for our domain. Yeah. Backend frameworks apparently support that. And for these sub-URL behaviors, we can be like, okay, look up what the short URL to the long URL is, and then redirect to the long URL using HTTP status 301. Yeah, and then return the long URL alongside so that the browser automatically redirects. Done. Okay, this actually took some effort of research on my end because I never knew about the 301 or 302 stuff. And I wasn't sure how the backend APIs would define or handle like sub-URL behavior. Like if you take your domain name and then do a slash and add your hash to the end of it, apparently they just handle it really well. Yeah, and then you can define APIs. Okay, that's how you do a URL shortener. This took like half a page of notes. Okay. Cool. This took an hour and 18 minutes. That's fine. I think I'm done for today. Yeah. At first I thought this was going to be really easy, but it still took some amount of learning and thinking for me. There was definitely some stuff that I didn't know about this. Oh yeah. Do you want to compare to my guess in the beginning? I was actually kind of close. We needed two APIs. One to shorten, one to lengthen. Maybe I should just call this lengthen, the second API. I think I got this backwards too. Short URL, out is the long URL. Yeah, I said that we needed a master database storing the long URL to a short URL. I think I got this kind of backwards, right? The short URL should be on the left, so it becomes the primary key, so that's indexed, and the fetch will be faster, I guess. I was missing a cache. I was right about the load balancer. Yeah, actually I was pretty close. It's just that the implementation details I wasn't too sure about. Like I didn't know that backend frameworks could handle sub URL behavior. And that 301, 302 exists. Cool, we're done. Oh, that still took some work. Okay, I'm gonna hop off then. Thanks to everyone who came. Thanks Mythic. I cannot see who else is in chat. My chat only displays the first 1, 2, 3, 4, 5 messages or so. So whoever else is here, thank you. I appreciate. I'll see you next time. Have a nice day. Bye.